This is 3.7 graphs of functions. We're going to be sketching graphs. We're going to use the vertical line test, which we've kind of already talked about. And then we're going to use vertical and horizontal shifts and also some reflections to help us sketch graphs of different types of functions. So let's start off with sketching a graph. So let's say I have the function h of x, and this function says negative the quantity x minus 1 squared. Okay, so I need to graph this. So obviously it's not in slope-intercept form, right? It's not in point-slope form. So I need to use that one method that we learned at the very beginning on sketching, making a table of values to figure out some ordered pairs so that way I can connect the dots and form a line. So let's say we plugged in -1, 0, 1, 2, and 3. So we just get to pick any x that we want. These are the x's that I want to pick. So h of x, that means I'm going to evaluate it for -1. Okay, so that means I'm plugging -1 in and following order of operations to simplify. So I do grouping first, I do parentheses first, so -1 minus 1, that'd be a -2. Drop down everything else. So now I need to do my exponent, -2 squared. That means -2 times -2, which would be a +4. And then I have this negative out in front, so I get -4 for my answer. Okay, so the ordered pair here is -1, comma, -4. All right, let's evaluate for 0. So I'm squaring -1, and I get a +1. And then that negative out in front makes my ordered pair 0, comma, -1. Go ahead and evaluate for 1, for 2, and for 3, and let's see what you get for your answer. Okay, for h of 1, I got 0. For h of 2, I got -1, and for h of 3, I got -4. So the next thing, after we make our chart of values, we're going to plot those points. So I'm going to go to -1 on the x and -4 on the y. 0, -1, 1, comma 0, 2, -1, and 3, -4. Okay, so this doesn't appear to be a straight line. I'm just going to connect them in order. And then we hit 0 and we come back down. So it looks like an upside down U, kind of. Okay, we call this a parabola. And you're going to find that a parabola in either direction is always from any equation that has x being squared, any type of x squared. So here I have an x, and then I'm squaring the outside of that x minus 1, so it formed a type of parabola. I'm going to skip piecewise functions and how to sketch them. I'm going to skip the domains and ranges of piecewise functions. So let's get to other basic functions. I talked about how an x squared function is a parabola shape. Okay, so f of x equals x squared has a point at the origin and it's pointing upwards. Okay, and it's going to go through 1, comma 1 and -1, 1. This is your normal parabola. This is like y equals x squared, except instead of y, now we're using f of x equals x squared. The constant function, we already know that y equals a number is a horizontal line, right? So now instead of y equaling a number, it's f of x, this is a function, equals a number. In this case, it looks like 1.5, right? It could be any number though. C just stands for a constant number. Okay, so it's a horizontal line for a constant function. And this was a parabola. Okay, then we have the identity function. Y equals x is the identity function instead of y. Remember, now we have this function notation. f of x equals x, which goes through the origin. And if y equals x, this is in slope-intercept form, right? It has the m is 1 and the y-intercept is 0. So we're going up 1 over 1. This is a straight diagonal line here. Okay. Absolute value function. If y equals the absolute value of x, except we're not using y, we're using the function notation. So f of x equals absolute value of x looks like a v. Starts with the origin, right? It has a slope of 1 on either direction. Over here, the slope is -1. Over here, the slope is +1. Absolute value function looks like a v. The square root function. So f of x equals the square root of x. It looks like just a half of a parabola and it's turned sideways. Okay, so this parabola, this direction, but without that other half. So it starts at 0 and it curves up to 1, 1, and then it's just going to kind of keep curving. That's the square root function. And then we have the cubed function. So f of x equals an x cubed, any type of x cubed, right? It could be x minus 1 cubed. Anything like that is going to have this type of form where it intersects at 0, it bends upwards through 1, 1 on the right, and then it bends downwards through -1, -1 on the left. So those are the basic graphs of the functions. And we're going to talk about how different types of transformations affect them. Like I just got through saying, what's the difference between x cubed and if I had x minus 1 cubed? How is that going to change my graph? I said it would be the same shape, but it's going to look a little bit different. So let's get into transformations. Actually, I do want to mention, I know we talked about it, but you probably didn't add it to your notes. So here it is, the vertical line test. A graph is going to be a function if no vertical line intersects it at more than one point, right? So this red dotted line is only intersecting the graph at one point. So this one would be a function. But over here, this one's not a function like we talked about because this red line is going to hit twice. Okay, and remember y squared, and we said that's not a function, but x squared, it's okay. All right, so this one's a function, this one's not a function. So that vertical line test, now it's in your notes. Okay, transformations. We have two different types of shifts. We have vertical, so up and down, and then we have horizontal, side to side. Now a vertical shift upward. A vertical shift upward is when we add a number at the end of our function or at the end of whatever we're doing to x, okay? A downward shift is when we subtract a number after our function, after whatever we're doing to x, okay? Notice that the subtraction happens outside of the function. It happens after. Same with the addition. It happens after. Those are vertical. Okay, this will shift it up or down. But then look at horizontal shift. So let's say we want to shift the graph to the right. Now it's kind of backwards because typically when you go right on a coordinate, those are positive. But when we shift right, we're subtracting a number, and notice now it's within our function. So it's x minus something in a radical or in an absolute value or in a square, right? Those are the different types of functions we have. We have square root, we have square, we have cube, we have absolute value. If we're doing anything inside of that square root, absolute value, or cube, like subtracting, it's going to move right. If we're adding a number within that function, it's going to move to the left. Okay, so we have left, right, up, and down. It depends on the sign. Here's what I'm talking about, the difference between a vertical shift and a horizontal shift. Look at what's being done to x. It's being square rooted, but what else is under the radical? It's a -2. Okay, so because the function itself is square rooting, and we're subtracting underneath that function, underneath that square root, that follows the horizontal shift. We're not subtracting at the end. This is not the square root of x and then -2. This would be downward shift. We're subtracting at the end. But what we have here is subtracting within. So a subtraction within is a horizontal shift to the right, that many units. So we look at our absolute value of x function. Normally, it would look like this, right? And the reason I know that is because of this slide here, the basic function starts at 0, 0, and goes up. It's like half a parabola. So how are we going to shift this red line? Well, we said that we're subtracting inside, so it's a horizontal shift, and subtraction means we're going to the right 2 units. So we take our origin point and we move over 2 units and we plot a point, and then we graph this line. So our final answer here is the green line. I'm shifting it. I move the red line over to the right 2 units. Okay, let's look at h of x. It's the absolute value of x and then -4. Okay, so what's being done to x is absolute value, but this -4 is at the end. It's not inside the absolute value, right? It's not x minus 4 and then close off the absolute value. So this is a vertical shift, right? And we're subtracting on a vertical shift, we're going to go down 4. Okay, so the normal graph of an absolute value is a V, with a slope of 1 here, the slope of -1 here. So I'm going to take this point at 0, 0, and I'm going to go down 4. 1, 2, 3, 4. Plot a point, and then draw my new V. So this green line is my final answer here on x, absolute value of x, -4. Okay, the other type of transformation we have are reflections. Okay, so we can either reflect across the x-axis, which means you flip it either side of the x, or we can flip it across the y-axis, so flip it on either side of the y. So just like we have to be concerned about whether we're subtracting on the inside or on the outside, we have to worry about the parentheses here, whether we are taking a negative in front of our function or taking a negative within our function. Okay, if we're taking a negative in front of our function, we're going to flip it across the x-axis. If we're having a negative inside our function, we're going to flip it across the y. So let's look at this example down here. We're squaring x, right? This x is being squared. It's not saying, hey, square negative x, it's saying square the x, and then they have a negative out in front. So it would be different if it was written this way. But because the negative is out in front, we're flipping it over the x-axis. So let's first draw x squared. It's a parabola going through 1, 1, and should go through -1, 1. But now if I'm going to flip it over the x-axis, I'm going to flip it downwards, right? Because now it's pointed up, so I want to flip it in the opposite direction, and the u should be going this way. Okay, so this was an x-axis flip or reflection, which means the red is my final answer. Okay, here I have the square root of -x. So the square root is what I'm doing to x, and look what's with it underneath. So the minus sign or the negative sign's in the function, it's in the radical. So I need to flip it over the y-axis. The original function of the square root looks like this. So if I'm going to flip it over the Y, now I'm flipping it in this side. So instead of pointing right, now it's going to be pointing left. So again, the red is my final answer. The blue was the basic function that I started with. So this slide here, super helpful to you, knowing what all the basic functions do. This chart, super helpful to you, vertical and horizontal shifts. And this chart here is super helpful for reflections.